Hello, Stat 200, and welcome to Lesson 11. This week, you'll be learning about one-way analysis of variance, typically referred to as ANOVA. We have less than a week between Lesson 10 and the final exam, so this is going to be a mini lesson. There are only two key topics this week. First, the one-way analysis of variance, and then pairwise comparisons, specifically the Tukey method. A one-way ANOVA compares the means of three or more independent groups. You can think of this as an extension of the independent means t-test that you learned a few weeks ago. When we learned about hypothesis testing, the issue of running multiple tests was discussed. If we want to compare more than two groups, we should not just run multiple t-tests, because the actual alpha level overall would be greater than 0.05. Instead, we run an ANOVA. It looks at the differences across all of the groups at once and keeps the true alpha level to 0.05. When you're conducting an ANOVA, the sampling distribution can be approximated using an F distribution. As always, this is dependent on a few assumptions. The sample should be approximately normally distributed, and the sample standard deviation should be similar. Like chi-square, ANOVA will always be right-tailed. So when you're constructing an F distribution to find your p-value, it will always be a right-tailed test. Also, like the chi-square distribution and the t distribution, the F distribution has degrees of freedom. There are actually 2 degrees of freedom for this type of test. One is just based on the number of groups, and one that is based on the sample size along with the number of groups. The test statistic is an F test statistic, also known as the F ratio. It's a measure of the variation between groups divided by the variation within groups. Let's look at a side-by-side box plot so I can explain the difference in between and within groups variation. Here we have 3 independent groups: the control group, treatment A, and treatment B. Between groups variation is a measure of how different these 3 groups are. Assuming that these are normally distributed samples, the median shown on the plot would be approximately equal to the mean. I mention that because ANOVA compares means, but a side-by-side box plot, which is often used to display data with an ANOVA, actually shows the median. But if they're normally distributed, the mean and the median will be equal. So the between groups variation is comparing the means of the 3 groups. Within groups variation is looking at the variability within each group. It's a measure of the sample variances. The ratio of the between groups to within groups variation is our F ratio, or F test statistic. ANOVA is sometimes referred to as an omnibus test because it gives us information about all of the groups at once. This is what an ANOVA source table looks like in Minitab Express. Different softwares will use different terms. Here, factor is our between groups variation, and error is our within groups variation. You can see that there's only one F value and one P value. This particular ANOVA is statistically significant because our P value is very low. This means that the overall ANOVA model is statistically significant. The means of the 3 groups are not all equal. But this does not tell us which groups are different from which. We'll need to do a follow-up test, known as a post hoc test, to determine which pairs of means are different. Your textbook does not cover any specific pairwise comparisons, but the online notes will introduce you to Tukey's Honestly Significant Differences test. There are many different post hoc tests. Tukey's test is popular because it makes all possible pairwise comparisons. Minitab Express will give you 2 different pieces of output with all of the possible pairwise comparisons using the Tukey method. This is the first table. Any groups that do not share a grouping letter are significantly different. Here, none of the groups share a letter, so all of the groups are significantly different from one another. This is the second table that you'll get. This is actually the one that I prefer to use. It computes the t-test statistic for every possible pair and gives you an adjusted p-value. So these p-values are adjusted to take into account that there are 3 pairs that are being compared simultaneously. This prevents having an inflated alpha level overall. This concludes the Lesson 11 overview video. If you have any questions this week, please post them to the Lesson 11 discussion board on Canvas, and best of luck as you prepare for your final exam.